Hi friends, welcome back to Edupedia world. In our last lecture, we read about rotation and torque. Today's lecture will understand what a couple is, we'll understand its mathematical treatment, and then we'll read about equilibrium of a body. So let us begin with today's lecture. Let us begin today's discussion with the definition of couple. Couple is defined as a pair of force which are equal in magnitude and opposite in direction, and they are not applied along the same line of action of force. Not applied along same line of action of force. Now what does this mean? Let us see with an example. Suppose there is a wooden plank or something kept over here, and if we apply a force F perpendicular to the plank in this direction and another force again of magnitude F but in the opposite direction perpendicular to the plank, then this two pair of force are known as a couple. They are equal in magnitude, they are opposite in direction, and their line of action is different. How come? The line of action for this force is this, and the one for this force is this. So there is a separation between the line of action of force, which we can call as D. Therefore, this pair of force meets all the criteria that is needed for a couple. They are equal and opposite. As a matter of fact, requirement for rotation is a couple. There cannot be a rotation without a couple. So a couple is required to produce rotation. You might ask that in our previous lecture we produced rotation in a body with just one force. So let us go back to that example and see what was happening there. We took a plank or a rod which was pinned over here, which was free to rotate about this point, and we had applied a force in this direction. When this force was applied, the body started rotating, and apparently there is just one force here, but as a matter of fact, the hinge present here, the pivot here, which is supporting, is taking the whole load of the external force, and as a result of that, it is producing a force equal in magnitude and opposite in direction, and ultimately this and this pair of force forms the couple in our example previously shown. So we can see from this example that we actually do need a couple to produce rotation, else the rotation will not be there. I think this gives a better picture. Let us try to imagine some real life examples where there is presence of couple to cause a turning effect. If you remember opening a tap, what do you do while opening a tap? You apply force in two different points and irreversibly in different directions. What you are doing is basically you are creating a couple which is leading to torque and helps in rotation of the tap. Let's take another example. If you imagine opening a door, what do you do while opening a door? You push the door at a location, maybe the doorknob. You apply a force on the doorknob, and the hinge is like the pivot here, which creates a equal and opposite reaction, rather equal and opposite force, and the force at the doorknob and this force created at the hinge form a couple and leads to the rotation of the door, effecting in the opening of the door. Well, now we have some qualitative idea about couple, and we discussed some examples representing couple. Now let us quantify the effect of a couple. Like we had quantified the effect in our examples previously by defining torque as the force into the perpendicular distance. Here too, moment of couple is defined, or effectively it will be the torque. So let us write the moment of couple, moment of couple. It is defined as the product of one of the force, product of one force, which can be either of the force because both are the same force, and perpendicular distance between the line of action of force, line of action of force. What does that mean mathematically? That means the moment of couple will effectively be equal to F times this perpendicular distance, F times D. Isn't it what this is supposed to happen from our previous experience? In our previous experience, if this was F, then we used to see the perpendicular distance, which was this distance, which actually is the distance between the two forces, F. So this scenario and this scenario are exact parallel, and obviously in this scenario the moment was F into the perpendicular distance. So it has to be F into D in this case too. A couple of points worth mentioning here is that the first point is we need to assign the direction of the moment of couple. For this example we saw here, the magnitude is F into D, but the direction is in this force leads to this direction and this force leads to this direction. So effectively it is a clockwise rotation. So we need to assign the direction in a direction in a particular sense, which for this example is clockwise. The second thing is that this distance D between the two parallel force, the perpendicular distance D, is given a special name as couple arm. So when someone says couple arm, it means the perpendicular distance between the two forces of a couple. Therefore, the moment of couple can also be defined as the product of one of the force, either force, and the couple arm. Don't get confused by hearing the term couple arm. With this, we have an idea about couple. Next, let us study about equilibrium. We have read till now that forces result in a change in state of the body. If it is in state of rest, it might start having motion. If it is in a state of uniform motion, there might be an acceleration. But is it possible for the body to stay in its state of rest or of uniform motion under the application of force? Actually, it is possible when there are multiple forces under special scenarios. What do I mean by this? I mean that if there is a box which is lying on a table or the floor, and if we apply a force F in this direction, and if we apply another force again F but in the opposite direction, then though there are forces being applied on the body, they are equal and opposite and cancel out each other, resulting in no change in the state of the body. Therefore, the body continues to maintain its state, and this scenario, this situation when even under the influence of multiple forces the body continues to maintain its state, it is called that the body remains in a state of equilibrium. So let us define what equilibrium is. When a number of forces are acting on a body, produces no change, no change in the state of rest or motion of the body, then it is said to be in equilibrium. Now we understand what equilibrium is. There are two different kinds of equilibrium. The first is called static equilibrium, and the second is termed as dynamic equilibrium. What is static equilibrium? Static equilibrium is when the body remains in the state of rest under the influence of force. Remains in state of rest. And dynamic is when the body remains in state of uniform motion. Let's first see an example of static equilibrium. In fact, this example which we discussed, in which the block staying on the floor continues to stay on the floor under the action of multiple forces, is an example of static equilibrium. So I will not go and discuss another example, rather I will jump into dynamic equilibrium. Dynamic equilibrium, on the other hand, is the body remains in state of motion, uniform motion, let's say, under the application of several forces. One of the examples of dynamic equilibrium would be the raindrop falling. What is so special about a falling raindrop? When a raindrop is falling, from high distance, that is from a cloud, while it is about to reach the earth, the raindrop attains a uniform velocity. You say, why should it attain a uniform velocity? There is a force of gravity acting, which is W, and there is a force of friction which is caused by viscosity. Viscous force, I am writing it. Will not go into the details, but there is a uniform magnitude opposite direction force due to the air resistance, and as a result the body will remain moving at a constant velocity, and that velocity is known as the terminal velocity. Therefore, we have seen an example of static equilibrium and an example of dynamic equilibrium. The conditions of equilibrium are: the resultant of force is equal to 0, that is, there should be equal and opposite forces, and the second condition is that the sum of moment for all forces acting on the body is also equal to 0. Why is this important? This is important because imagine a scenario when we have two forces which are equal and opposite, but they are not along the same line of action of force. What will that do? We just saw a while back that will cause rotation, and involvement of rotation is not equilibrium. So we have to have zero force and we have to have zero moment of rotation. These are the conditions of equilibrium. To sum up, in today's lecture we read about the couple, we understood what it is, we understood its mathematical sense, then we understood what equilibrium is, what the different types of equilibrium are, what are the conditions for equilibrium to exist. In our next lecture, we will learn about the principle of moments, and we will discuss certain numericals to understand how equilibrium is maintained. Till we meet again, have a great day. Goodbye.